Let's take a look at this one-dimensional motion question that shows that Lori is walking 15 meters east in 5 seconds, 8 meters north in 3 seconds, then 5 meters west in 2 seconds. The first part, A, is asking us to solve for the total distance traveled. Now you have to remember that distance is not a vector, so it's a scalar quantity, meaning that direction can be ignored here. So all we're going to do is add up the 3 distances that are listed in the question. So we have a distance of 15 meters plus 8 meters plus 5 meters, which gives us a total distance traveled of 28 meters. We are ignoring north, south, east, west, or any angles at this point in the question. Question B asks us to solve for her average speed. So speed again is just a scalar quantity. So average speed is going to be equal to the total distance traveled divided by the total time elapsed. So here we have a total distance of 28 meters, which we solved in part A. And your total time we can get from adding 5 seconds plus 3 seconds plus 2 seconds for a total time of 10 seconds. That gives us an average speed of 2.8 meters per second, and just make sure that your units work out properly given the way you've written them in the question and what the question is asking for you to solve. Part C is now asking us to solve for her displacement. So displacement is a vector quantity, so direction is going to matter here. I'm going to define north and east as my positive directions, which means that when I'm solving for my total displacement, anything west and south, I'm going to have to rewrite as a negative value. So my displacement is going to be equal to displacement 1 as a vector, 2 as a vector, and 3 as a vector, which gives us 15 meters east plus 8 meters north plus 5 meters west. Now we're going to have to rewrite this 5 meters west using our north or east directions here, which means I'm going to rewrite my question 15 meters north, or sorry, 15 meters east minus 5 meters east. Because we need to acknowledge here that if I change my direction, then I have to change my sign. I'm going to add my 8 meters north at the end. This leaves me with a net of 10 meters east and 8 meters north. So I'm not quite done yet, because now what I'm going to do is my vector addition to get me my final answer. So what I'm going to be looking at is the components here. So I have traveled 10 meters east. That's this first one. And then I'm going to travel about 8 meters north. That's the second one here. When I have these, this kind of part of the right angle triangle, what I'm going to add now is the hypotenuse. The length of that line, as well as the angle of that line, is going to give me what my total displacement is. So this is my displacement that I'm solving for here. I can solve for dt, or the total displacement, by using Pythagorean theorem, or by rewriting Pythagorean theorem so that it looks like this. And then I have 10 meters squared plus 8 meters squared. That's going to give me 12.8 meters. So that's the length of that line. I still need the angle. So I'm going to call this angle alpha. And I can use my tan ratio, which tells me that tan alpha is equal to opposite over adjacent, which is 8 over 10. And that's meters. So those meters are going to cancel out. By rewriting that, I get my angle alpha is equal to tan negative 1 of 8 over 10, which gives me an angle alpha of approximately 39 degrees. And that tells me that my final answer, so this 39 goes here. I have a final displacement of 12.8 meters, and that's east 39 degrees north. The last part here is asking me to determine her average velocity. So velocity is another vector value, which means that the magnitude of the values plus the direction is going to be important here. So I'm going to use my displacement from before, as well as my time from before. My displacement from part C was 12.8 meters east, 39 degrees north. And my time, which is time is always a scalar value, so we don't need a direction there, is 10. Accounting for significant figures, I get 1.3 meters per second and include the direction because velocity is a scalar value.